Alright guys, let's jump back into some practice problems with molarity and dilution. I'm going to be moving a little bit faster this time, so if you turned up your speed, you might want to check that. So the first few questions here are just review. If you've been watching the videos that I've done so far, then these should be pretty easy. What is the definition of a solute? If you read through those, then you should definitely be marking D. It's a substance which dissolves in a solvent. And for number 2, which of the following describes a saturated solution? Remember, saturated was when you added as much as could be dissolved in a given solvent at a given temperature. So for this, that is consistent with B. Now number 3, honestly, you'll understand that one will apply more for the material that's on test 3 after we do reactions, so don't worry about that right now. Alright, number 4, let's go. What's the molarity of a solution that has 10 grams of KOH dissolved in a total volume of 250 milliliters? So once again, this is a problem where you have the amount and the total volume of solution. So set it up as a concentration to where it's 10.0 grams of KOH per 250.0 milliliters. Now you're supposed to be finding molarity. Molarity is moles over liter. So your job is to change those units and get them to moles per liter. To go from grams to moles, grams of KOH per mole of KOH, you need to refer to the periodic table. 1 mole of KOH, when you go add it up, is going to be 56.11. 1 potassium, 1 oxygen, 1 hydrogen. So that will allow you to get from grams of KOH on the top to moles of KOH on the top. So you're halfway there. Now for the milliliters, we need that to go to liters. So milliliters to liters, that factor is there's 1,000 milliliters in 1 liter. Once you do that math, milliliters will cancel, leaves you with liters on the bottom. So your answer will be moles of KOH per liter of solution. And we're going to do the math such there's a 1 on the bottom and we only have a single number in the numerator. When you plug and chug through there properly, you're going to get 0.713, 3 sig figs because of the 10.0. Rewrite that 0.713 capital M, and the substance you actually calculated the concentration for was KOH. Alright, next problem. Potassium nitrate, KNO3, is a formula weight of 101.10. It was nice of them to give you that, but please be prepared for that not to be there. You should be able to get that formula weight yourself, and you should know that you need it without it being given in the problem. So just be prepared. So, how many grams of this salt must be dissolved in 250 milliliters of solution to give a molarity of 0.330 molar? So we're going to start with the 250 milliliters, and we're going to get that to liters because we're going to want to use the molarity as a conversion factor from liters to moles. Then we can go to grams. So looking at this, we're going to go from milliliters to liters. So that's 1,000 milliliters per liter. Now we'll be in liters, and we can use moles per liter, the molarity. So remember, it's written as 0.330 capital M. So that is moles per liter. We need liters on the bottom to cancel. And moles will be on the top. And it is KNO3 that we're talking about. So the 0.330 goes with the moles, and that is per 1 liter. Alright, so let's see how we've done so far. We've gone from milliliters to liters, and then from liters to moles. We're supposed to be finding grams, so we need to keep going. And now we need to do this one more step to go from moles of KNO3 to grams of KNO3. Moles on the bottom so it'll cancel, grams on the top because that's the unit we want for our answer. So where does this information come from? Grams per mole. That is the periodic table. If you go add up 1 potassium, 1 nitrogen, and 3 oxygens, then you're going to end up with the same thing it gives you in the problem, which is 101.10. You have to know that goes with the gram unit, and it's per 1 mole. So now if you plug and chug through there, well, before you do plug and chug, you should check your units, make sure you're good. Moles cancels. Grams of KNO3 is what you would have left doing the math this way. That is what you were asked for, so you're good to go. So now when you go in and use your calculator and plug and chug through there, if you do that correctly, you're going to end up with 8.34 grams of KNO3. So basically you just told yourself you need to go in the lab, you need to find the potassium nitrate, you need to measure out 8.34 grams. You need to get a 250 milliliter volumetric flask. You're going to fill that flask about half full of water. You're going to add that 8.34 grams of KNO3 slowly with swirling until you get all of the KNO3 to dissolve in water. Once it's all dissolved and it's taken up the amount of space it's going to take up, then you add water to the flask until the meniscus goes all the way up to the mark at 250 mils. Mix that up really, really well, and in the end you will have your 0.330 molar solution. Alright, number 6. What is the molarity of a solution formed by adding 30 mils of 2.50 molar HCl solution to a 100 ml volumetric flask, then filling the flask to the mark with distilled water? So what are we actually doing? We're taking a small volume of this solution, we're adding it to another flask with a total volume of 100 mils, and adding water up to the mark, and it wants to know what is the concentration of the new one. So this would be your concentrated solution. So this is going to be V1 and M1. And then the second volume after dilution is going to be the 100, and the final molarity is what we're solving for. So M1V1 equals M2V2. Alright, the molarity of the concentrated is 2.50 molar. The volume there is going to be 30.0 milliliters. Second molarity is what we're looking for. And the volume of that solution is going to be 100.0 milliliters. Now, often people are like, how do I know that these were 1, the 30 and the 2.5 were 1s, whereas the 100 ml was a 2? You could have called this V sub 2 and M sub 2 and called this V sub 1 and that M sub 1, and your math is going to be exactly the same. What has to be consistent is that you know these go together, and that this one and this one go together. As long as you have them on the same side and matched properly, you will be fine. So once you do the math, the milliliters will cancel. You're going to be left with units of molarity. We called that M2. When you plug and chug, you're going to get 0.75. But if you watch your sig figs, you need 3 sig figs because of the 30, so it's 750. Capital M molar, and the solute in question was HCl.